Hi, everyone. It was nice to see your report. Hi, guys. How are you? How are you, Lakshmita? What are you doing in school?
Oh, we're reviewing like points, lines, and
Oh,
rays.
is it easy, mother?
Yeah, it's pretty easy.
Okay. How are you, Akshara? Are you studying geometry in school? No, right?
I am.
Okay. How is it going, ma?
It's going good.
Okay. How are you finding it? Are you using what we are learning here?
We're so I took this class and I took another geometry summer camp, and I'm using like they're teaching everything you taught me and this summer camp taught me.
Nice. So you're able to use them at school?
Yeah.
That's nice. That's very nice to know. Okay. Okay. Ashwath, it was good to see your reports. Darsh is not doing that at school. Harshat, how are you managing? Did you go over the previous ones a little bit?
Previous what? The
Ye-
classes?
Yeah.
I'm doing it.
Okay, you take time. Okay, it will take time. I understand that. Okay, Arya Sricharan, how was the homework, Arya Sricharan? Arya, how was the homework, Arya? Darsh, you submitted the homework?
Yeah, I'm pretty sure. Did I? Let me
Looks like
see.
you didn't. Huh?
I did it. I don't know if I submitted it. Which one? Oh, transformations. No, I was catching up on the other ones. Sorry.
Okay, but if you lose track, right, it will be hard to follow through, right, ma?
Yeah, but it's just like it's a lot. I have schoolwork to do. I also have this. I have to catch up. So like I'm trying to manage.
Yeah, I understand, but this is something we discussed. Okay, where is the PDF, Vikyat, in your submission? Vikyat, did you submit the PDF?
For some reason it didn't let me submit it. I've tried, but can I just email it to you later after class?
Why? What was the error?
I don't know. It was just saying there was an error when trying to attach a file.
Okay, is your storage full? Is the email storage full?
Maybe I'll check.
That is the problem if the server is rejecting. If you have your email ID storage full, it won't let you submit at all, ma.
Okay, I'll double check and get back.
Okay, and Nikita, are you checking your answers or not, Nikita?
I am, but I checked for the first part, I think.
Okay, the second part?
I did it at night yesterday and I forgot to.
Okay, but you have to, ma, then only there is some accountability. You got it?
Yeah.
Okay, and Samanvi, did you have any questions?
No, man.
Okay, and Ishan, it was very, very nice to see your work, but absolutely I don't see any work right. Ishan, he's not in here. Okay. Okay, Ishan's is not in here. And others, what comments did I have? Harshit, you submitted, right? Harshit, did you understand everything?
No, I had some doubts on dilations.
Dilations was not given to you at all. I don't think then you're reading the instructions given.
Oh, I just printed out the homework pages.
See, it's important to read what is in the instructions as well, right?
Okay.
Ashwath, did you have any questions?
It was like I did transformations and reflections easily, but rotations and dilations were harder for me.
Guys, did I not mention that you don't have to do those because I did not teach you? Then is it my problem? Let me check, guys. I'm not
Wait,
sure.
where's the instructions?
Let me check, ma. Maybe that I missed as well. I will check and let you know.
You said to do only part 1 and part 2.
Yeah, so yeah, oh, it is there, ma. I'm checking right now. Anvi, did you have any questions?
I only had one trouble, but it was with the dilation one, and that was only one
See,
problem. The
guys,
rest was just
are you all checking whatever is given to you to do? Meaning, are you all checking? Meaning, are you all checking what has to be done before you do? Okay, let me share. Maybe I did not add it. Let me check.
Miss Priya, you did add it. I remember
I just
I
didn't
read
see
it. Sorry.
Yeah, it is given there. So why are you all doing more, right? Then you'll have a lot of questions if you were not taught, isn't it? So let me show you guys, okay? So it's so important to read through instructions, guys. Be it any homework here or at school, you will be benefited by doing it, right, ma? So see here, transformations part 1 and 2. Do you see it, Anvi?
Mhm.
You didn't see this? See, usually I give out the instructions properly. You cannot do everything and come back frustrated. I don't want you to get frustrated, you know? Make sense?
Wait, I didn't know that the part 1 and part 2 was part of the homework. I thought it was just like half of it is like part of the unit and then half of it is a part of the other transformations unit.
So then you have to ask, right, Harshad? What is the, what is that? What do you mean by this? Part 1 is here, part 2 is here. So if you didn't understand, you have to ask, right? Clearly, I said you're going to do part 1 and part 2. Does that make sense? No, it's see, whenever we make a mistake, we learn, right? It's not even a mistake. You did more than what you have to do. So you should be happy, but at the same time, I don't want you to get frustrated. Oh, I didn't understand. I don't want you to get that feeling. That's why I'm telling you with a good intent. You did more than what was expected out of you. And I don't want you to feel frustrated because of that. That's why I keep pushing that. Okay. So, yeah. So, let's move on. Okay. Always read through instructions and then only you should do. And Kavin, were you able to fix your problem?
Yeah, I was. Thank you.
Okay. Are you checking your answers, Kavin?
Yeah, I am.
Okay. That's good to know. Okay. So, let's go ahead. Okay. Let's do, okay, I don't know whether you all remember rotations, maybe reflections. Okay, first rotation, let's do. Okay. Let's rotate by 90-degree clockwise. Let's rotate by 90-degree clockwise the point 1, 2. Let's see. Let me go ahead and share what with you, the notes page where I have tried, right? Let's hard base wait. Hey Jay, how was the homework? I saw all the corrections. It was amazing.
Yeah, it was
Did you have
good.
any Huh?
It was okay.
Okay. So, okay. One thing what I do not remember with your assignment is, did you do part 1 and part 2?
Yeah, translations and reflections.
Yeah. How about Jay? Did you do 2 parts?
I'll check. Give me a second.
Oh, you forgot. Okay. Okay. Let's go ahead and do rotations. Okay. See, in translation, what did you do? The translation you did x comma y was changed to x plus a y plus b, correct? So translation is movement left and right. This is translation, right? The next one was reflection. In reflection, what did you do? Here was reflected on any line. It need not be x or y axis. It can be on any line. So that is reflection. Translation is a sliding. Reflection is what? Flipping, right? So whenever you flipped on the x-axis, the y-coordinate negated. Whenever you flipped on the y-axis, x-coordinate negated, right? So you can also reflect it on some lines for which you understood some of the formulas. So now we go ahead with rotation. So these are all rigid transformation. Why they are called rigid transformation? Meaning, basically, this we discussed in the first class, right? When we
Yeah.
discussed, yeah. So rigid transformation means it comes, these all come under rigid transformation. One, translation, reflection, rotation. Why they come under rigid transformation? Because the pre-image, the original image, and the image, the figure that I get after doing the transformation, are congruent. Okay. If it is not a rigid transformation, you call it as a similarity transformation. What is that similarity transformation? What is an example of that? Example of that is dilation, which can make it, which can be a reduction or enlargement. Meaning, you're going to make a small figure into a big figure, or you can make it into a smaller figure as well. Here, the scale factor is greater than 1, scale factor is less than 1. Any questions? You're all with me?
Miss Priya, I did part 1 and part 2, coming back to your question.
Yeah, nice. I did see that. Yeah, I did. Yeah, I really, on top of my head, I don't remember what I saw in yours. Some of them have done all of it. That's why I was wanting to understand. So, did you all get this, guys?
Yeah.
Okay.
Yes.
Sometimes we did only these two in the first class. In the first class, in the sense, first time we discussed transformation, we did the translation and reflection pieces. So you see how much is pending. We have rotation, we have similarity transformation. Okay. To simply tell you the facts that these are pending, but there's much more, guys. Okay. Meaning you need to understand a combination of transformations. All that combination of different transformations we'll do and try. And then you have to you have to understand about the notations we use for each of them. The way we are discussing right now is we are just building on your 7th grade level. 7th grade, you already learned all of this. Then we are building on top of it a little bit more. Okay. But as a part of geometry, I want you to understand some notations as well, which will be really useful. Any questions till now? Okay. Now, let's go to rotation. reflection, right? In translation, you didn't have anything like a point or a line, but in reflection, there was always a line of reflection, a mirror line. That was a mirror, we called it, right? Line of reflection was always there. That line was the spine, and then you flipped it. Either on that line, you can flip it. The line can be, the line of reflection can be horizontal or vertical. You can give any equation to that line. Okay. If it is x-axis, on which you're flipping, that line is y equal to 0. If it is y-axis you're flipping, that line is x equal to 0. Makes sense, guys? Now, we are going to go into rotation. What is rotation? Rotation is a turn, correct? That's a rigid transformation. Why? Because the pre-image and the image are both alike. Amira, are you here? Amira? Okay, I don't know what is going on. Let's see. Okay. Now, coming to rotation, right? Let's say we have, I talked to you about a point, right? Let me talk to you about a point. 1, 2, 1, 5. 1, 2, 1, 5. 1, 2, 1, 5. These 2 points, let's. First, we'll consider this 1 point, 1, 2. If we want to rotate it, let's say we want to rotate it 90-degree clockwise. 90-degree clockwise, we are going to rotate it. One thing understand, guys. 90-degree clockwise, I want to rotate it. If I want to rotate it, what is meaning? Around what I am going to rotate it? Around what I'm going to rotate it? So around a point, you see. So my origin is the point of rotation. Usually that is the base. If they don't say it, then it is the origin. You're rotating around the origin. What does that mean? What does that mean to have the origin as the point of rotation? You draw, meaning literally a connector between that point that you rotate and this one. You're going to rotate 90-degree clockwise means, you know what I'm going to do? 90-degree clockwise means for this line, I'm going to draw a 90-degree clockwise direction line. 90-degree clockwise means moving like this. So I'll draw this line. Now, whatever is the distance in here from the origin, I'm going to cut it off here. So that is your 90-degree rotation. Did that make sense? 1, 2 now becomes what? It will become what it will become? If you rotate it 90-degree clockwise,
It'll become
Hmm.
2 comma negative 1.
2, negative 1. That makes sense. This is basically 1, 2, right? You're reflecting 90 degrees. So,
I think
this,
it's 1 comma negative 2.
Emma, you're not reflecting. You're not reflecting, right, Ma? So let's go ahead and do 1, 2, 1, 5. Let's go ahead and do this. I really want you guys to know. Nice thoughts though. I'm going to share my screen with you all. Are you able to see my screen, guys? Are you able to see a Desmas calculator?
No,
No.
Black right now.
there's just a black line in the middle.
Okay, wait. Let me see how I'm going to show you. I don't know. Let me see. Yeah, this should be good. Okay. I wanted to show you just points, right? I want to show transformation of points. Let me show you of points. I don't know how to show that. Let me see whether a Desmos calculator can help with that. Oh, yeah.
Oh, the Desmos graphing calculator?
Yeah, would it help me? I'm
We
wondering.
use that in school.
Yeah, Ma, but would it help me in showing you the points? I'm thinking, wait. Let's see. It should actually. Let's see. I don't know what to do. Oh, that's slide, but I really want to show, 1 second, guys. I really want to show rotation 90-degree clockwise. That's what we did, right? Let me see if I can do. Uh, yeah, let's see this. One second, guys. Let me see whether I can do it for you guys. 2, 4. But then I think I'll be able to show you is what I'll feel. Let me see. Okay. One second, guys. I don't know whether I'll be able to show this here. Mm, can I draw the... Oh, I can't do that. Okay, I can't do that. Let me see. I'll share with you and you can as well help me. Let me see. I'm trying to plot the point and after that, I don't know how to show you guys. Let's see. We were thinking of 1, 2, right? So I drew the point. You can as well help me understand. So when I want to show the rotation 90-degree, right? Can I drag the point? No. See, this is 1, 2. Okay, did not understand the notation. P dot y minus P dot x should give you that 90-degree clockwise, right? Yeah. So let's see. Let's try at least. Would I be able to draw this one? Let's see, guys. I don't know how to show it to you though, but I really want to show it to you. This one, right? Now, I'm going to draw here something similar. Here is your line, right? Now 1, 2, this is 2, this is 1, right? Somehow I should be able to show you guys. Let me see. Let me see. Otherwise, do you all know GeoGebra, guys?
Yeah.
Okay. GeoGebra, please make use of GeoGebra, okay? Let me see if I can show you in GeoGebra. I want to show you, then only it makes sense.
Auntie, what is GeoGebra?
See, GeoGebra, here. Do you
Is it
see
like
it?
Reddit?
No, it's not like Reddit. It's another mathematics website.
Stack Exchange?
No, see,
Slide.
I am sharing. Are you able to see the GeoGebra website?
Yeah.
Okay, you're seeing it, right?
Yeah.
Okay, so what do I do? Let me put it 90 degrees. Okay, let's see. Okay, now guys, I'm going to rotate this 90 degree. Let's see.
Auntie, it's 85 degree.
Yeah, 85 degree. I want it to be 90 degrees. Okay, how do you do that? So here, are you able to see? Are you able to see the GeoGebra website, guys?
Yeah.
Okay, now let's consider this point 1, 3, right, guys? They're rotating it 90-degree anti-clockwise. I'll go with that, okay? 1, 3, right? Now, draw a 90-degree angle. How do you draw a 90-degree angle? From here, see, this is 1, 3. So, 1 unit on the x-axis, 3 unit on the y-axis, right? From the origin only I'm doing, right? So, on the x, it was in the horizontal direction, it was 1 and 3. But here you're going to do the reverse actually. Up and then to your left. Does that make sense? Then only it will rotate. Why I'll tell you. Okay, 90-degree clockwise means the basic fundamental way is you draw the connector to that point A, right? You're rotating 90-degree counterclockwise. So draw a 90-degree angle and then you need to make sure that is at the same distance. What is this distance? This distance by Pythagorean theorem is 1 square plus 3 square, right? So that same distance on that 90-degree line you need to plot. This is 1 square plus 3 square, right? So this has to be a 3, this has to be a 1. Then only it will be 1 square plus 3 square. So that point comes here. Now, next I'll go to the B point. Okay, this is my connecting point. This is my connecting point, right? 0 to B. From the origin, see, it's like a rod. Okay, from the origin, I point out the rod to that point and then again draw a 90-degree counterclockwise we are rotating, right? Now, what happened here? This was 4 units to the right and 3 units up, right? Here, what would happen? 3 units on the x-axis and 4 units up. Does that make sense, guys? Does it make sense?
Yes.
So,
Yeah.
here, yeah. And then C, let's try this one. See what happened. So here is the point. So my rod should point out to that point. Now I'm going to rotate 90-degree counterclockwise. So where will be my 90-degree angle? This is my 90-degree angle for the green, right? Now, how was this? 4 units right, 1 unit up. But this is my 90-degree counterclockwise angle. So it would be 1 unit on the x-axis, 4 unit up. Did that make sense? Then only this distance is the same, guys, right? So then this will become A dash, this will become B dash, C dash. This is the 90-degree rotated triangle. Any questions, guys? Any questions? Now, how did we come up? This is very hard to do every time, right? That's why we come up with formulas. 1 comma 3 now became what? Minus 3 comma 1. So, 90-degree counterclockwise rotation of x comma y will be what?
Negative x, y.
Minus y
I
comma
mean,
x.
negative y, x.
Yes, you all got it? Okay. Okay, now I'm going to erase out all this. Okay, I'm going to achieve the next one. What is the next one? This one they have given, right? Now, the same origin, let it be. Okay, now I'm going to rotate it. Would I be able to move it? No. 1 second, let me see. I want to show. I'll do one thing. Here itself, I can show you. Okay, now let's see. Yeah, see, okay, 90-degree clock, we rotated 90-degree counterclockwise, right? Now, 90-degree clockwise, if I want to rotate, that is 270-degree counterclockwise, right, guys?
Yeah.
270-degree counterclockwise is the same as 90-degree
Clockwise.
clockwise. So, I did 270-degree clockwise. So, that is the same as 90-degree clockwise. Or I can call it as 270-degree counterclockwise, right? See what has happened? 1 unit and then up is 3 units, right? For the point A. Now what would happen? This is my rod. I'm pointing out the rod at my point and I have to draw a 90-degree line, right? Which is my 90-degree line? You remember by Pythagorean theorem, the hypotenuse has to be the same, 1 square plus 3 square, right? But what would happen here if I draw the 90-degree marking from here, right? This will be right smack here. As a result, still I need to keep that 3 and 1. 3 and 1. Remember, that distance is the same. So, the point will be here. Any questions, guys? Again, for the second point, what do I do? 0 to B, will point the rod. Okay. Then what will I do? Hold on, I'm not able to see that. See, this is hard, guys.
You can just full screen it, right?
I can't, Amma.
Oh.
You scroll down using your mouse.
Yeah, if I do that, the drawing
After you full screen it.
after I full screen it, no, I'm not even able to see. That's okay. That's okay. Let's see. You know what? I should be able to adjust the screen somehow. Oh, um, no, that GeoGebra is not, see this one and GeoGebra is not great. Okay, so you understand how it's being done? I'm fine, guys. See, 0 to A, 90-degree angle. Understand one thing. What is this? 1 and 3, right? 1 and 3, X and Y will be 3 and 1. That's all. 3 and 1. Any questions, guys? Did you get it? Okay, so that's how you need to do all the three. So as a result, what did we arrive? 90-degree counterclockwise, 90-degree clockwise, right? So x comma y became minus y comma x, right? So now what will happen to x comma y? Okay, let's consider this. This was
Y
1
comma
comma 3. This one is 3 comma minus 1. So what should be the rule?
x,
Correct.
y comma negative x.
Correct. Now 180-degree counterclockwise or 180-degree clockwise are both one and the same. What would happen, you think?
Minus x comma minus y.
Okay, let's try this one. This is my line, right? The same line, I'll just keep going, right? So 180-degree means the distance has to be the same, right? But it'll be here. So uh, can I draw it like this? Will it be like this? Will it come here? Am I making sense? So that would become what? What it would become?
Negative 1 comma negative 3.
Negative. That's what I am thinking. Is it minus x comma minus y then?
Yeah.
Yeah.
Wait,
Yeah,
I have
I'm
a
thinking.
question.
Mm-hmm.
Does rotating 180 degrees and reflecting across y equals negative x the same?
Exactly the same. Make sense? See, Harshad, several of the transformations will be same. You see, meaning what you can do by rotating by some angle, you can do by reflecting as well on a line. Okay. Similarly, you can as well slide. Two slides can even be the same as one two reflections can be the same as one rotation as well. You can do whatever you want with transformations. Okay, that is why we are also going to study combining different transformations as well as we move on. You got it? It's nice. It's a good find that you're finding all this. Okay, so now see, that's the best part in geometry. Those are the extras we'll study here. Any questions, guys? Okay, now go ahead. I've given you all the rules now, right? 180, what did we do for 180 degree? Yes, minus x comma minus y, that was right. Okay, now let me ask you this. 1 comma 1 comma 2, 1 comma 5, 3 comma 2. 1 comma 2, 1 comma 5, 3 comma 2. Can you do 270-degree counterclockwise and show me? Quick, send the points. Are you able to do, guys, or are you getting confused? The next thing is a little confusing. That's why I'm making sure you're all getting this.
Miss Priya,
Yeah, ma?
I'm getting a little confused.
Where, ma? I asked you 270-degree counterclockwise. 270-degree counterclockwise is what, ma? What is 270-degree counterclockwise? Means what? That is equal to Arya. Are you using these at school, Arya? Whatever we are learning?
Miss Priya?
Yes, Arya, I'm listening.
Yeah, we use these at school. I mean, a little bit sometimes.
Sometimes, then what are you discussing in school?
Right now we finished domain and range. We're now going on equations and inequalities.
Arya, I understand, but the thing is, Arya, oh, you're doing algebra 1 in school, huh? Are you able to catch up? See, this you won't even discuss in school then. You're going to write the acceleration exam, right, Arya?
I think so.
Okay. So these should be your answers, guys. If you didn't get it, there is a problem. You have to shout out now. Did you all get this? Yes, Arya, you got it. It is always about the origin, Arush. Kavin, you understood, right, Kavin? Ashwath, did you understand? Samandi, you understood? Kavin, did you get it?
I
Yeah, I
sent
think
you my
I got my
answer.
answer already.
I got the right answers.
Yeah,
Oh,
same.
yeah. Vikyat, thanks, Vikyat. Appreciate it. Darsh, Jay, you're not answering. Did you not understand?
I did. I was just typing them.
Okay. Anvi,
Miss
how about
Priya, I
you?
answered.
Yeah. Anvi, how about you? Did you understand? Yes, ma'am. See. Anvi, did you understand?
Yeah, I was just about to type in the coordinates in the chat.
Okay. Oh, the geometry class, I have to leave for a prayer commitment. Okay, I see. Johan, okay, good. Okay, let's go ahead, guys. You understood this is what I'm thinking. Now, you know the hard part of geometry we did not study earlier is you're not going to rotate about the origin. That's going to be the tricky part. You're not going to rotate around the origin. Okay, you do one more and then we'll go with that. Okay, 1 comma 2, the same points. Let's do at least 1 point only. Okay, 1 comma 5, 180-degree around the origin. 1 comma 5, 180-degree counterclockwise around origin. You always should ask quickly. If you can say, we can move on. Okay, nice. Jay, is that right? I thought both should get a negative sign, right? 180 degrees, right? Both should get a negative sign, right? Jay? Arush, that's correct. Darsh, that's correct. Harshad, that's correct. Ashwath, that's correct. Kavin, that's correct. Arya, correct. Ma, Lakshmita, did you get it? Yes. Okay, guys, we'll move on. Now, the biggest part is we're not going to rotate around the origin at all. Okay, that's the hardest part, right? Okay, now let's say we are going to have the same points 1 comma 2, 1 comma 5, 3 comma 2. 1 second, guys. My writing pad went off. Just give me 1 minute, it'll turn on again. So let's see 1 comma 2. I'm going to use the same 1 comma 2. What are the other points I gave you? 1 comma 2, 1 comma 5, 3 comma 2. 1 comma 2, 1 comma 5, 3 comma 2. See, the thing, why is it becoming harder? We are going to rotate this around the point P minus 1 comma 2. We are going to rotate around the point. We are not going to rotate around the origin. Okay, this is going to be a hard point. Okay, let me first show why is it difficult. Okay, 1 comma 2 is our point, right? Let's say this point is A. Okay, A is 1 comma 2. Now, what is making it difficult is we are not going to draw it to the origin. I don't have the laser point or the rod at the origin. Now I have it at minus 1 comma 2. I have the rod here. Minus 1 comma 2, the rod is in here. This is the point of rotation. So I extend the rod to this. Extend your rod. Then what happened? Let's say I want to do, what did I say I want to do? Let's say I want to do 90-degree clockwise. I'm going to rotate 90-degree clockwise around this point. If I want to rotate 90-degree clockwise, what would happen, guys? Clockwise I want to do. You see? So what would happen? This is a horizontal line, right? It will become a vertical line, right, guys? So the same distance, this distance of 2, right? This distance of 2 will come here. So where would it come if I rotate around this point P of minus 1 comma 2? Where would it come?
Minus 1 comma 0.
I am thinking so. I'm thinking so. How do you get this? Every time you can't be doing this, right? I told you there is a very nice, easy way of doing it. But this one you'll have to remember, guys. If you're rotating around a point, it is difficult, but you understand what is happening. The rod is no longer at the origin. The rod is the point of rotation is here. So the rod extends from here. Okay. So then to that line, I draw a 90-degree. But this one you can't be doing for everything like this. Okay. Once you understand how it is being done, there is a quicker way. One thing is, let's say this point as h comma k. The point around which you are rotating is h comma k. Let's consider. Okay. In that case, you know what I do? I subtract that from A. I subtract that from A. So what would happen? 1 minus minus 1. 2 minus 2. So I subtract that from the point I need to rotate. So what does it become? What does it become? 2 comma 0. Any questions, guys? I subtracted minus h minus k from that point, right? I had an answer. Now do the ordinary rotation. How do you rotate 90-degree clockwise around the origin? How do you rotate 90-degree clockwise around the origin? X comma y will become
Y comma
y comma y comma
minus x.
minus x. So you did the ordinary rotation. You got it? First you subtracted the point of rotation. Then you rotated 90-degree clockwise as usual, as if you did the origin, about the origin. You did that. And finally, you subtracted, right? Now you add back h and k to the rotated point. What you need to add? You need to add a minus 1 to it. 0 plus a minus 1 and minus 2 plus a 2. What is the point? Minus 1 comma 0. See? You got it. Did you guys get it?
Yeah.
Shall I do one more?
Yeah.
Okay. Let's consider the point B. I'm going to do one more, guys. I know this is confusing, but you need to listen. B is 1 comma 5. I need to rotate around the same point 90-degree clockwise. Now, my origin is not the point of rotation, right? Immediately, as soon as I see that, I will subtract the h comma k. What is subtracting h comma k? Subtract minus 1, subtract 2. When I do that, the point becomes what? Tell me, guys. One of you tell me.
0, 3.
0 ah. 1 minus minus 1 is what?
2 comma
2,
2
3.
comma 3. Correct. Thanks, Ishan. Very nice to get your answers. Yeah. 2 comma 3. And after that, what happens? You subtracted. Now you have to perform rotation. First, subtraction of the point of rotation. Then you need to perform the usual rotation. What is the rotation you will perform?
Flipping the digits, then negating the x.
Yeah. So what do you do? What will happen? 2 comma 3 will become
3 comma negative 2.
very nice. The last one, you made a mistake here by subtracting. So what you need to do, you need to add it back. Add it back means add a minus 1, add a 2. What would happen? It would become 3 plus minus 1 is 3 minus 1, 2. Minus 2 plus 2 is a 0. Does that make sense, guys? Does that make sense?
Yeah.
Anvi, did you understand? You got
Yes.
it. Rotation around a point is a tad bit tough unless you understand what we are doing. Akshara, did you get it?
Yeah.
Okay, now try for this one. I'm doing the same thing on 3 comma 2. Now you get me the answer for that. Done, guys?
No, still one more time.
Yeah, take your time. I didn't mean to rush you. Take your time and let me know. Done, guys?
I don't understand it. Can you explain it?
Yeah, first what you should do. Come on, let's think out loud, Darsh. What did I say? What did I ask you to do first?
You should the point is -1 and 2, so you should subtract those from the point.
Correct. The 3 comma 2 point only you're going to rotate. So let's take the 3 comma 2. What should you do? You figure out loudly, Darsh, so you will not forget. Go ahead. I'm writing.
So I think it should be 3 minus 1.
No. First of all, don't say the answers because everybody is working. So just tell me the process. You have 3 comma 2. So what should you do with it?
So first I'll subtract the 2, and then I would rotate it with the 90 degrees because I converted it to around the origin. And
Yeah,
then
but wait. What you will subtract from 3 and 2? 3 comma
the
2
H
is
and
what?
K.
H and K you will subtract. Okay, go ahead and subtract. And then you will do the usual rotation rule.
Yeah, around the origin.
And then you add back the H comma K.
Yeah.
You do. Now you will be able to do. There's nothing you didn't understand, I think. Go ahead.
Yeah.
I'm waiting for your answers, guys. I need each of your answer. I'll not move if I don't get an answer. Because this is quite important. Akshara, that's not right. Harshad, that's right. Ashwath, that's right. Be confident. Kavin, that's not right.
Wait, Miss Priya, what are we supposed to rotate 3 comma 2 around? 1 comma 2 or HK?
Okay. It's very confusing, right? The way I wrote it down.
Yeah.
You know what? I am not even able to write on the board. Why? Okay. 3 comma 2 minus 1 comma 2. 3 comma 2. 3 comma. I'm not able to write, guys. I don't know what is going on. Okay. 3 comma 2. I'm going to rotate around the point minus 1 comma 2 90 degree clockwise minus 1 comma 2. This is your point of rotation. You got it? This is your point of rotation. Okay. This is the point that you're going to rotate. Point that you will rotate. Okay. Now, what rotation are you going to do? That as well I'll write down. 90 degree. What did we say? 90 degree clockwise we said, right? Yep. Try this one. Try, guys. Wow, Arya Sricharan. Is that right, Arya Sricharan? Almost. Yes, you edited it. Correct. Darsh, good job. Johan, can you try the Y alone? X is correct. Very nice to see your answer, Johan. But please keep doing. Go ahead. Just because you're not on video, don't. Nikita, do the Y, ma. X seems correct. Ishan, perfectly right. Oh, impressive, Ishan.
That was for the other question.
Oh, okay, ma. I'll wait for your answer. Kavin, your Y is right, X is incorrect, I feel. Let me check. If you know the rotation around the point, then it becomes very easy, guys. Yeah, Kavin. X alone you need to redo.
Okay.
Anvi correct, ma. Anvi, you got it? But the thing is, you need to remember this, okay? If you want to subtract, see, it's very easy. Subtract the point of rotation, then what do? Then you do the usual rotation around origin, then add back. Yeah, Kavin, that's right. Vikya, that's right. Who still has a question? Lakshmita, did you get it? Okay.
Yeah.
Did you get it, ma?
Yeah. I
Lakshmita,
know some
that's
answer.
incorrect, ma. That's incorrect, ma. Lakshmita, I don't know what is incorrect about it. Lakshmita, that was incorrect. Can I help you?
Wait, I think I see where I went wrong.
Okay. That's the nicest way of learning. Figuring out really helps you. That's right, Akshara. Good job. Arush, correct. I'll wait for Lakshmita, please. Samandi, you got it right, ma? Ashwath, you got it. Lakshmita, I'm just waiting for your answer. I'll wait. No pressure though, but I want you to get it. Yeah, Lakshmita, you got it. Good job. Can I move on, guys? So you all got it. Can I take it? Rotation around a point. That was the biggest thing for today. Okay. Now I'm going to move on. Let's see. Do you all know what is rotational symmetry? What is rotational symmetry? Okay. If a figure can be rotated less than 360 degree around a point. Okay. And the pre-image and the image appear to be the same, then it has rotational symmetry. Does that make sense? Meaning, let's find this out. I have a 5-pointed star. 1, 2, 3, 4, 5. Okay, now a 5-pointed star. Okay. Now I'm going to rotate. These are the points A, B, C, D, E. Now I rotate it such that A goes here. Basically, 4, 5. Okay, now A goes here. E, D, C, B. Do you see it's the same star again, but the places of A, E, D, C, B has changed, right? 360. Now, do you see? So, how many times I can rotate like this such that the same figure is seen? Within 360 degrees, around one full circle, how many times I can rotate? How many times I can rotate so that the image and the pre-image will appear to be the same. That is called the order. What is the order of rotation for this one? You tell me. What is the order of rotation for a 5-pointed star?
5.
5. 360 divided by?
5.
So 5 places, meaning you can shift A to E, A to D, A to C, A to B. Correct, guys? So there are 5 different places where you keep A, then the same image will come, right? So the number of places where you can keep A and then get the same figure is the order of rotation. Here, the order of rotation is 5. This object has rotational symmetry. What is rotational symmetry? When you rotate it and keep it. What are you rotating? A, you're bringing it to this point. That is rotation, right? So you're rotating it by that angle, right? Still, the image and the pre-image are the same, right? So order of rotation is 5 and magnitude of rotation. How much did you rotate? Magnitude of rotation is 360 by 5. What is 360 by 5?
72.
What is it?
72.
72. So 72 is your magnitude of rotation. 72 degrees you shift it, you rotate it. Okay. Like that you can rotate 5 times. So the order of rotation is 5. Magnitude of rotation is 360 by 5. Any questions, guys? Any questions?
No.
Okay. Can I say that you all got it? Okay. How about this? A square. A square. Can you guys tell me a square, does it have rotational symmetry first of all? Does the square have rotational symmetry? Does the square have rotational symmetry?
Yes.
Yeah, it does. So what is the order and magnitude of rotational symmetry of a square?
360 by 4.
Please send the answer in chat. I would really like everybody to answer, right?
Miss Priya, I can't see anything on your screen.
No, ma?
No, there's like nothing.
I know why. Okay. I did not write anything, right? I just asked you the question, right? That's why you don't see.
Oh, I think my audio wasn't working that time. Sorry.
Darsh, are you listening?
Yeah.
I don't want that to be happening, Darsh.
No, sometimes it like bleaks out. That's why like other classes I ask you, but I thought to leave, but like this I thought this time it was like you weren't talking, so.
Yeah, that's why sometimes I put down the question. See, I don't want you to be doing anything else as well. You got it? I'm very particular about it, Darsh. Okay. So I asked you what is the order of rotation? Does this have rotational symmetry? First of all, is it rotational symmetry? Does this figure possess rotational symmetry? If yes, then tell me the order of rotation and magnitude of rotation. Order
Okay.
and magnitude of rotational symmetry.
Okay.
That was the question. Order and magnitude of rotational symmetry.
Okay.
Rotational symmetry. Same magnitude of rotational symmetry. That's right, Ashwath. You got it. Ashwath, did you go over the previous syllabus and were you able to understand? Yes, Ishan, that's right. Arya Sricharan, one answer is correct. Harshat, one answer is correct. Where is the order? J, correct. J. Order and magnitude, don't confuse. Magnitude is the number of degrees. Order is the number of times you can rotate. Got it, guys? Okay, let's move on. So it should have been 4. Order of rotational symmetry is 4 and magnitude was 360 by 4. Any questions for me? Okay. Now, do you all know what is dilation, enlarging and
Reduction.
reduction? Now, the corresponding sides of the image and the pre-image are in dilation. The corresponding sides of the image and the pre-image are how?
Congruent.
Proportional.
I think it's proportional, right? Congruence comes only for rigid transformation because the size varies, right? Similar. Good job. So in dilation, if this is my pre-image, right? My image becomes this or my image becomes this, correct? This is what is dilation all about, right? So when I say ABC, the angles don't change, but the size, right? AC becomes 3AC or 2AC or 10AC, 10 times AC, or it can even become 0.5 AC. This is your scale factor. You got it? So the AC is not congruent, but AC and A dash C, A dash C dash are proportional. The corresponding sides are proportional. You got it? Why they are proportional? This is 1 AC, this is 3 AC. It's multiplied by 3. That's what is proportion, right? Meaning you have a multiplication factor, right? The corresponding sides are proportional. Whereas in rigid transformation, where the image and the pre-image are the same, the corresponding sides are congruent. Any questions, guys? Any questions? One thing in dilation, right? Pre-image times scale factor. Any side scale factor will be equal to the image. Did you guys get it? Pre-image side times scale factor will be the image side, the corresponding image side. You see? How did I get A dash C dash? A dash C dash is the corresponding side. What can I say here? A, B, C, the order A, B, C, order of letters is important. Triangle ABC is similar to triangle A dash, B dash, C dash. Did you get it? The first two letters AB is equal to, AB is equal to 1 by 3. Let's say the scale factor was 3. Okay, I can say AB is the smaller one. 1 by 3 A dash B dash I can say. Or I can say A dash B dash will be equal to 3AB. Any questions, guys?
I have a question.
What is it?
If the scale factor is 0, would it be the point of dilation?
No. Scale factor 0 means it becomes a point, right? It's
Yeah,
no
would
longer
that point be
single
the point of dilation?
The point of dilation. Good. For now, we take the point of dilation as the origin.
Okay.
Why are we taking the point of dilation as origin? Let me show you. Good question. Now, this is my figure. I want to draw a figure like, okay, let's try this one, guys. Okay, this is my figure. Let me finish with this, okay? Now, if I want to dilate by 2 times, okay? You know, from the origin, this is A, B, C. This is how I dilate. You should know how we dilate. Okay, the rod, remember our rod that goes and points to all the 3 figures. Okay, and 3 points. I extend that. I extend that. I extend this. This is what is dilating, making it bigger. You got it? Now, with this distance, let's say I want to dilate it by 2 times. Okay, I multiply by 2. I multiply by 2. So from here, 2 hops. That is my point A dash. Then what? B would be this and another of that. C would be this and another of that. That's C dash. Now connect. So this A dash B dash triangle is a dilated figure. Make sense, guys? So there's always a point of dilation around which you dilate. You get it? Point of dilation need not be origin. That's different. That's a different complicated story. So now the point of dilation is always the origin, and this is how you dilate. With respect to the origin, you extend the line and double the distance or triple the distance or whatever is the scale factor. Make sense?
Yeah, but the question I was asking is if the point of dilation, if it's like not at the origin and you're using scale factor on it, if you do a scale factor of 2, and then you would start from, like, instead of starting from the pre-image, you can start from the point of dilation, right?
Always you start from the point of dilation. The point of dilation is here. What will happen? From here you'll dilate, okay, 0 from that point to A, that point to B, that point to C. Now, you will extend that figure. You got it?
Yeah, but if the scale factor is 0, then the point
Scale
of
factor is 0, then you can't get the figure at all.
Yeah, then the answer would be the point of dilation, right?
The scale factor is 0. Yeah, that the scale factor 0 means it won't be the point of dilation. For if it is the origin, it's fine. But if it is not the origin, the scale factor can't be 0. You got it?
Oh. Okay.
Yeah.
So it's undefined?
I see what you're saying. You cannot have scale factor 0, right? It's either reduction or enlargement. If it is congruent, then it becomes a rigid transformation. So it has to be less than 1 or greater than 1. If it is equal to 1, the scale factor, then it becomes another figure just like our pre-image. Then it will go to rigid transformation. This is non-rigid transformation.
Okay.
So scale factor can never be equal to 0 here.
Okay.
Does it make sense? Okay.
Yeah.
Now I'll give you homework on scale factor, dilation, but I won't give you homework on dilation not around the origin. Does it make sense, guys? So the only homework on rotation and dilation. Make sense? Okay, next week we'll explore a lot more complicated tasks. Okay, this week you'll only have rotation, but rotation not about the origin you will have because we have already discussed that. Okay, so you will do part 3 and part 4 of the PDF. Any questions for me? You will do only part 3 and part 4. Does that make sense?
Yeah.
Okay, any questions for me, guys?
No.
Okay, please see instructions and then do. Don't get frustrated. Okay. Okay, guys. I'll see you all next week. But next week it's going to be more complicated. Same transformations.
Thank you. Bye.
Bye, Miss
Bye,
Priya.
Bye, Miss
guys.
Bye,
Priya.
Miss
Bye.
Priya.
Bye.
Bye, guys.
Bye, Miss Priya.
See you all next week, ma.
Bye, Miss Priya. See you next week.
Bye, ma. Nikita, good
Bye,
job in
Miss
the class.
Priya.
Bye, guys.
Miss Priya.
Yes, ma.
So since I did all 4 parts on accident, should I just delete the part 3 and part 4
Oh,
from?
please. No, no, no. You've done such a good job, right? Make sure you understand. Go back to the previous weeks and do that this week.
Yeah, no. What I'm asking is, just keep the. Should I just keep what I've done in reflections and
Yes, don't even submit this homework.
oh, should I like? I was thinking I could resubmit just reflections
Yeah,
and
you can just resubmit. That's a good idea. I really like that.
yeah, and then I'll just do like a new for one
Yeah,
for
ma.
rotations and dilation since I learned it.
You don't need to redo. Submit the same PDF where you have already done.
No, but like that time I didn't know everything, so I just want to redo it to get more practice.
Perfect.
Okay, thank you. Bye.
Bye, ma. Daddy?